Okay, here we go. Almost done with chapter 1. These are your notes and the information you need to be successful when you complete 1-6. This lesson is all about two-dimensional shapes, and this is just kind of an overview. We will do more work on these as we move throughout the year. But the part you need to know for chapter 1, just the introduction, is this word polygon. You need to know that a polygon is a closed shape where all of the sides are segments. So I'll just write the sides are segments. And you will see lots of different polygons. I'm just going to sketch out one polygon. Another definition that sometimes you see is it has many sides, poly referring to many, and gon referring to like sides, so many sides. A triangle could be a type of polygon, even though it only has 3. Pentagon, octagon, nonagon, dodecagon, all sorts of things. When we name a polygon, we name it by its vertices. So the vertices are like the points or the corners where the sides come together. And this will be important as we go later on, but this would have lots of different names. But the thing you need to know is that when you name it, you want to go around in some sort of circular way when you name it. So this one here, you could go clockwise and call this A, E, D, C, B, but probably 99% of the time you would just be calling this one A, B, C, D, E, because it's alphabetical and that kind of makes more sense. But I wanted to point out that you could start with any letter and go in either direction as long as you're going in order around that shape. Okay, so I think really the best way to kind of point out what a polygon is to show some examples of polygons and things that are not polygons. So this chart, I took it directly from your book, so you can refer back to it. You don't need to copy all of these things down. I wanted to show you though why these are not polygons. This one here, even though all of these are straight line segments, this is not closed. So it has kind of an opening right here, so this would not be a polygon because it's not closed. This one here has curved sides, so because all the sides need to be line segments, these would not be line segments because they're curved. Anything where it's just like a circle or an oval, that is a shape, but it's not considered a polygon. The problem with this one is this kind of like tail thing hanging off. Another part of the actual definition of polygon says that each line segment has to only intersect others at their endpoints. So because this line segment's intersecting it here, and that's not the endpoint of this line segment, that's the issue with this one. And the same thing here. This line segment's not just intersecting endpoints, it's also intersecting someplace in the middle of this other one. So these are not polygons. All of these are polygons, just different types. So we will be classifying these, so knowing like specific names for them. But part of the questions will just say, is it a polygon or is it not a polygon? And explain if it's not a polygon. So you could use things like it's not closed, or it's curved, or it doesn't intersect at the endpoints. Okay, it'll also ask you that if it's a polygon, to label it as convex or concave. The definition of convex is a little bit maybe confusing if you read it out of the book, but what the definition of convex says is that if you have line segments on a polygon, and if you were to extend those line segments out, so if I were to take this line segment and extend it out, that extension would never go on the inside of the shape. Concave, it would. So if I draw another picture of a polygon that's concave, do you see here that if I extend this segment, whoop, that got a little curvy, but if I extend that segment out, that segment or that line intersects, it goes inside the shape right here, that would make it concave. The way I remember this is concave like caves in. or it dents in, like it dents in here. It kind of goes back into itself. That's the way I always think of concave. If you would like a more formal definition, you can just copy that out of your book. But I think if you think concave, it caves in. Convex, it doesn't. Sometimes they'll call concave non-convex. But I'll let you use the word concave. I like the word concave because it reminds me that it caves in. Okay, something else. All of these are shapes you're going to need to know, with the exception of, I don't expect you to remember 11 as a hendecagon. Some books even actually call it an undecagon. We won't be using that, but I do expect you to know triangle has 3 sides, quadrilateral has 4, pentagon 5. You can think of like the Pentagon in Washington, D.C. to remember that one if you forget. Hexagon has 6 sides, and the way I always remember that is 6 has an X and hexagon has an X, so that might help you too. Heptagon is right after hexagon. It also has an H. Octagon, I think of an octopus. So with its 8, let's see, 1, 2, 3, I think I only got 7. With its 8 tentacles, octagon has 8 sides. Nonagon almost looks like the letter or the word 9. Decagon is 10. And then dodecagon is 12. So it's like do, like 2 plus 10 for decagon. And then anything else, and you can include 11 in this anything else, we're going to just call an n-gon. So that might be like a 13-gon. And you could just write it like that, or a 20-gon. And it will just tell you how many sides they have. There's all sorts of names for other shapes, but you're not expected to know those. You should definitely know 3 sides to 10 sides, and then 12 sides is pretty common, so please know dodecagon also. So you don't need to write this whole chart in your notes, but if there's maybe a few that you don't just remember, maybe adding those in, or if you need to make yourself some flashcards, because these words will be important for you to answer questions and stuff later. Okay, the next part is a little more vocabulary. You're probably familiar with the word equilateral. Like you probably talked about equilateral triangles in the past. Equilateral polygons would have all the sides be congruent. So all the sides are congruent for an equilateral polygon. So a good example of that might be an equilateral triangle. And I will do my best. I know that doesn't quite look equilateral, but what we'll do is we'll just add some congruency marks so that you know for certain that that's equilateral. Equiangular, maybe you could take a guess. All the angles are going to be congruent. And things could be equiangular but not equilateral, or equilateral but not equiangular. And a great example of a shape that you already know that's equiangular but not equilateral would be a rectangle. So all of these angles are going to be 90 degrees, but not all the sides are the same length. And then the word regular basically just takes both of these things and puts them together. So regular would be all the sides and all the angles. Oops. All the angles. Messed up on that one. Are congruent. And I cheated a little bit for this. I just drug in a picture, and this right here would be a regular pentagon. And they called it A, B, C, D, E, just going around in a circle when they named that. And notice that all of these angles have the congruency marks because they all have one arc, and all of the sides have congruency marks too. So that's the way we know that it is regular. So this is the way some of the directions are going to look. It will say name each polygon by its number of sides. So what that means is you'll count up the number of sides and tell if it's a triangle or octagon or whatever it is. Classify it as convex or concave, and then regular, or they use the word irregular, meaning just it's not regular. So for this first one, this has 1, 2, 3, 4, 5, 6 sides, so this is a hexagon, and it would be concave. And then it would be irregular. It doesn't ask you this, but this would actually be equilateral. But since it's not equiangular, we have to call it irregular. And for this one here, this has 8 sides. So 8 would be an octagon. Oh, this pen's kind of messing up a little bit. Okay, it is convex. And this one is regular because all of the sides are the same length and all of the angles are the same measure. Okay, we have one more piece of information, but before we do that, I have a question for you. So, why would you not play poker in the jungle? Because there's too many cheetahs. I know some of you guys are probably not enjoying that at this moment, but just trying to make this a little entertaining. I'll know that you're really watching these videos when you just start laughing, and then I'll just know. Okay, so the last piece is we are going to be finding area and perimeter of 3 basic shapes. And you've probably done all these before again, but this is just kind of a little bit of a review, but seeing how we're tying this stuff into geometry. So area of a rectangle. For area, what we can do is we can multiply the length times the width. And this works for a square also. For a square, they're going to be the same, so the formula might say it's the side squared. But if you just want to remember one thing, just remember it's the length times the width. And perimeter of a rectangle is 2 times the length plus 2 times the width. Or you can just think about adding all those sides together. That would get you the same answer. So the area of this rectangle is going to be 6 times 5.5. And when I multiply those things together, I get 33. And then the units on that, units for area, are always going to be square units. So that would be square feet. For the perimeter, I need to make sure I'm adding up all of those sides. So if it helps you to write out those other sides, you're just going to add them all up. Or you can think of the formula 2 times the length of the rectangle, which is 6, plus 2 times the width, 5.5. And when I multiply those together and add them up, I get 23 feet. For the area of a circle, the formula is pi times the radius squared. And they don't use the word perimeter for a circle, they use the word circumference. And if you remember circumference, they use the letter C, is 2 pi times the radius, so 2 pi r. And I remember as a student not really remembering which one was which. I could always remember pi r squared and 2 pi r, but I would kind of get confused as to which one was which until I remembered that area would always be square units, so that's going to be the formula that you include the square in. So in this picture here, this is not the radius, it's the whole diameter that they give you. So before I'm able to plug these numbers into the formula, I just need to take half of this diameter, which is 3.1, and that's going to be my radius. So for area, area would be pi times the radius squared, so pi times 3.1 squared. So when you multiply that out on your calculator, that's going to get you 30.2 after you round it to the tenths place. So since pi is an irrational number, if you plug that into your calculator, you'll get an irrational number also. You can just round that to the tenths place unless the directions tell you otherwise. And then for circumference, same thing. I'm multiplying 2 times pi times the radius, so the radius is 3.1, and when I multiply that out, that is 19.5 after you round it, and the circumference is just the length around that circle, so that would just be a number of centimeters for this one. Okay, and then lastly, our triangle, our area of a triangle is half the area of a rectangle. So half its base times its height. And you just need to know that the base and the height, we'll just say the base has to be perpendicular to the height. And then the perimeter, there's no nice simple formula. I'm just going to write up add all the sides. Sometimes they might call those sides like A, B, and C, and then they'll write A plus B plus C. You might see that in your book. I'm just going to write that you add up all the sides for perimeter. You can just remember that that's what you always do. You don't necessarily have to remember formulas for those. Okay, so the area, I need to find the base and the height, and since those have to be perpendicular to each other, these two segments here are the ones that are perpendicular. So the area is going to be half of 10.2 times 8. So when you multiply that out, that's going to give you 40.8, and that's going to be square inches. And then perimeter, when I add up 9.5 plus 9.5 plus 10.2, when I add up the actual sides of that triangle, you don't need to add in that 8 for the height. When I add up those numbers, that's 29.2 inches. So please let me know if you have questions on any of this stuff. I look forward to helping you in class.